Hello. So for my project, I decided to model NFL games by predicting the winning team using player data scraped from the internet. Again, the problem is to develop a model to predict NFL game winners based off of player statistics. The motivation for this problem is that such a model could have real-world uses, especially for gambling purposes. Sports gambling is a $1 billion industry, and an accurate model could be used to place statistically informed bets. And the model doesn't have to be used only for gambling. There are many other reasons one would want to predict outcomes of a sports game. Often, these predictions come from gut feelings, which will likely be biased, so my model could remove some bias from these predictions. A couple of the related works I looked at are this paper, A Hybrid Prediction System for American NFL Results. In this paper, the authors developed a k-nearest neighbors model that was highly accurate. It was above 80%. I also used a k-nearest neighbors model, but I found that it was less accurate than other classification models I used, which I'll talk about later. A possible reason for this discrepancy is that I used stats from individual players, while this paper's model used overall team stats. Another related work was a paper about modeling distances of javelin throws. In this paper, the authors found that a neural network model was most effective, which I also found to be the case for my model. So to get the data, I used web scraping on all 32 NFL teams' individual websites. This was slightly difficult because many of the websites were formatted differently. Fortunately, all the tables were the same format, but where the table was in the web page differed from team to team. Also, I'm downloading a large amount of data from 32 different websites, so the web scraping part of my program actually takes a couple minutes to run. Then I scraped each team's schedule along with which games they won or lost from ProFootballReference.com. The data cleaning was a very large part of this project. The most important part was standardizing the size of each team's data set. This was important because teams don't always have the same number of players at each position. For example, the Giants have only used one quarterback this season, while the Cowboys have used four. So therefore, if I wanted to use all the players in the data set when training the model, most teams would have many null values, which would skew the results of the model. To fix this, I only took a set number of players at each position for each team. I chose to use one quarterback, 3 rushers, 3 receivers, 5 tacklers, and 2 interceptors. This solves the problem and more accurately reflects a team's actual lineup. And then finally, I standardized the data using scikit-learn standard scaler. My data exploration involved graphing certain statistics versus the amount of points scored per game. This was from an earlier iteration of the pipeline, so it is not directly applicable to the final model, but I did learn some useful information, which is that trying to engineer my own features was less effective than just using the statistics as they are. As you can see from these 3 images, the correlation between total yards in a game and points scored is higher than either engineered feature, the difference in the total yards, or the percentage of total yards. So I concluded from this that it was better to use the statistics as they are rather than to try to engineer my own features. So here's an overview of my model. I chose to make an ensemble model because I had 5 different data frames containing different types of data that all needed to be combined into one model. The first step is to train a linear regression model using a random subset of the games from this season for each position, and then pass the data frame corresponding to that position through the linear regression model. This will result in 5 new data frames where every player has one value associated with them, which is a number from 0 to 1, roughly equivalent to how good that player is. Then all the resulting data frames are combined into one, with a row for every team and a column for every player. Then another data frame is created, which has a row for each game in the training data. Each row has the stats from the 2 teams in that game and the outcome of the game, and this is the data frame that is used to train the classification model. Then I tested 6 classification models to see which one had the highest accuracy. I used a logistic regression, decision tree, random forest, SVC, neural network, and k-nearest neighbors model, and used cross-validation with tenfolds to determine which model was the best. Here I've plotted the accuracies using a box plot to compare them. Neural network had the highest mean accuracy with 0.70, followed closely by logistic regression with 0.69. However, the differences between these two models was not statistically significant, along with most of the comparisons. The only p-values below 0.05 were from comparing the decision tree with the logistic regression, SVC, and neural network models. In conclusion, I think that the model works well, but it is not extremely accurate, and I think there are several reasons for this. First of all, when you get down to the level of looking at individual player statistics, there might just be too much noise to develop an accurate model. I tried to account for this by removing some features for the linear regression models, and this did increase the accuracy very slightly. I think another reason the accuracy is somewhat low is that predicting NFL models is simply a difficult problem. I looked at what games my model was predicting incorrectly, and many of them do seem to be upsets, where the worst team wins the game. This leads me to believe that the model does work well, but the problem is too difficult to model accurately. And finally, the data set I have is not perfect, because I don't have stats for each player week by week, just their overall stats for the season. This means that the model is essentially assuming that once scaled, a player's stats don't change too much week to week, which is probably mostly true but not perfect. However, because I am using a dataset of season total stats, the model is well suited to predicting future games. And finally, for fun, I use the neural network model to predict the games for this coming week. By the time you're watching this video, these will have already happened, so I guess we'll see which ones the model gets right. Interestingly, the model agrees with the Vegas Insider betting odds on all the games except the Texans-Lions, Giants-Bengals, and Titans-Colts games. However, at the beginning of the week, the two did agree on the Texans-Lions and Giants-Bengals games, so Vegas Insider must have new information that the model doesn't take into account, like the Bengals quarterback getting injured. So yeah, that's pretty much it. Thank you for watching.